Press.
All right, guys. So thanks for joining today. So my name is Prasad De Silva, and so this webinar is to celebrate the Global Encryption Day, and it's actually supposed to be on October 21st. So it's one day past, but this is one of the webinar series that we are hosting. In last year we have, and the previous year we had the same webinar series. Now. This webinar is actually coordinated hosted by Internet Society of Sri Lanka, and I'm just I don't want to go to what is Internet Society, because most of our the participant joined here is actually from ISOC Sri Lanka. So I would like to welcome you all, and then because the time is important, so because this webinar is around maybe 1.5 hours to 2 hours in long. So we need to start this one on time. Now with us we have our Internet Society president, and we have our executive members, and we have a few members from ISOC Global, and so welcome to you all. And I would like to introduce our two distinguished speakers. Our first speaker is Professor Gihan. So he's actually well-known character. He's graduated from University of MODERATOR in 1985 and awarded the doctorate in electrical engineering and computer science from the University of California. So in addition to being a professor in computer science and engineering, director of National Languages Processing Center at the University of MODERATOR, he serves as the domain registrar of the LK domain registry and advisor to TechCert in Sri Lanka, leading computer security organization. So Professor Gihan has been active in IT security and encryption for over 30 years, and has helped both organizations and individuals safely navigate cyberspace. Now, our so Professor Gihan will be talking about when you should not use encryption, and our next speaker is and here. Okay, our next speaker is Dr. Lakmal. He's a ICT professional, chartered IT security professional, holder of several prestigious certifications from the same area. So he's a university academic consultant and have more than 18 years of experience in lecturing and training in universities and corporate organizations. So Dr. Lakmal is a senior lecturer and consultant at Sri Lankan Institute of Information Technology, SLIT. So he already trained more than 15,000 professionals. Now, without further ado, we would like to start the session. So Dr. Lakmal would be delivering about blockchain security with smart content security and auditing. Now, here's how this session goes. Professor Gihan will start his first session, and then after the session, there's a little Q&A session. Then after that, Dr. Lakmal will do his session. After his session, we can have another Q&A session. Okay, so then without further ado, I would like to pass the mic to Professor Gihan to present his speech. Thank you. Over to you, Professor. I think you're on mute.
Right. So sorry about that. I hope you can hear me as well as see me as well. Also see my slides.
Yep.
Okay, good. So I will start. So I thought I will talk about, or I will give my title as when not to use encryption, since this is session on encryption for World Encryption Day, but I thought I will say so that we not use encryption. But of course, that's not really all I'm going to talk about. So I will talk about many basically just explain about sorry about that. Right. This is the Zoom window. Right. So I will talk about several things. So anyway, before I start, I'd like to thank International Society of Sri Lanka and Prasad and Pujani and all the other people for organizing this very important event, which will be uh, abused. And of course, I'd like to thank all the participants who are participating in this program. So let's continue. Uh, let's look at what is computer security. So when I say computer, I actually include things like uh, phones or anything else. So any other uh, devices. So I will not only worry about phone, computer, but I guess what is computer security. And you can say that a computer system is secure if you can depend upon it to behave as you expect it. Right? So this means, let's say you take not necessarily a computer, but let's say you take your phone and you open a particular app, you expect that app to do what it should do or what you expect it to do, and not, for example, take pictures of you or pictures of whoever is around without your knowledge, or open the audio and send the audio to someone else without your knowledge. So all of that, or maybe steal your credit card number, or whatever the bad things it might do. So if your system is secure, all the things on the system behave the way you expect it to. Of course, it's sometimes difficult to imagine what it is that you expect, but let's see. So the next question is your system secure? Right? So right now you are connected to this webinar on some kind of device. Right? Some you may be on a PC, some on a phone, maybe some on some other kind of device, maybe some on a room or something like that, or a smart TV, any other device like that. Now, do you know that system or any other systems you have, are they secure? Now, I would assume for most of you, the answer would be, well, I really don't know. Right? I doubt if any of you, including myself, can say, yes, I'm 100% sure that my system is secure. So let's try to see how we can make this more secure. What are the things which we want to make secure? Your physical devices, your PC, your phone, and also the server, which you may not see, but they are somewhere in Google or Facebook or YouTube or SLT or some other place like that, which provide you with all these services. Right? So if there is something wrong with any of the servers you use or to do anything, then you are not secure. Then the data. We'll talk about the data in more detail later, so we will get to that. Then, but I also want to talk about a couple of other things. First one or the third one is people. Now we might say, oh yeah, system is secure, all the computers are very secure and all the other devices are very secure, but what about the people who are using the system? Are they secure? What do you mean by that? What I mean is that people who use these computer systems are often the biggest problem. It is very easy to fool a person. So this is a good example. Let's say that you are the secretary to the chairman of a big company, and then suddenly you get a phone call saying, uh, I'm in a big, having a big problem. Chairman wanted me to print this report and read to him, but I don't have a copy. Can you give me the password to the server so I can download that thing, that file, because the chairman wants it very urgent. Now, most of the time, if the secretary wants to make sure the chairman gets his job done, they say okay, and maybe they will give the password or they will send the file or whatever it is, right? Because people often try to be helpful and people don't sometimes understand all the details of all the technical things. And also other people, not only you, but also other people need to be secure. Then the fourth one is trust. Now, I'm sure, or I don't know the answer, but you may have come across a condition where you made a transaction using maybe a credit card or something, and then you want to check to see if the transaction has gone, and then suddenly you find that say maybe you bought something for $100, but suddenly it shows that there is a transaction for $1, and the $100 one is not there. You wonder, oh my God, what has happened? Right? Of course, you're not too worried because you did the transaction for 100, but it was charged once. But if you call the bank, they will say, no, that's just the authorization. They will reverse that into a while, and you will see your $100 transaction in a little while. But if you don't know that that's what happened, you will see that you cannot trust this system. That you do something and the system does something else. And that very often happens. And also not only you, but if other people do not trust you or your computer, it's a problem. So this is where your computer or your phone or something could get infected by malware and start sending in all sorts of things. Right. So let's continue. Sorry. What is an attack? So an attack on a computer system is some unauthorized use of your system, or I would say your system has a behavior which is not authorized. And it could be by some kind of person or even due to natural causes. So it may be that you have a system failure, maybe your hard drive is failing or your mouse battery is going down and the mouse sort of moves here and there, or the mouse pointer moves here and there by itself. But it is some, you might think it's some kind of attack. And how can we mitigate this attack? So let's say you want to have your physical device, your computer here. What should you do? You should keep the device in a secure place. Now recently I was at a supermarket, and then this man, one of the employees there, spoke to the lady who was next to me and said, "Madam, you have left your computer and your wallet in your car, and you have come here." And then I also looked to see, yes, her card was somewhere else, and she was here, and in the car was nicely her computer and her wallet. Anybody could have taken it. So she took the bank and took it, but very often you do that. I will ask you, who leaves your computer, your phone on the table in your office when you go for lunch? Right? I'm pretty sure quite a lot of you will have to say yes to that. Right? You leave the phone on the table, then you go for lunch. And sometimes somebody could even unlock it without you knowing, or maybe they could just steal it and whatever. So you have to keep your device in a secure place. I mean, all these other techniques are not very useful if somebody actually physically takes your computer or your phone or your other device and has full control over it. Secondly, if you want to keep it safe, you should disconnect it from the network. Now that is easier said than done because obviously most devices, they are not very useful if you are not connected to the network, right? So you would want to most likely connecting to the network if you want to use it. Then data. Let's say you have some data, like this AM file. How can you control access to? If you want your subordinate to print that file, then you should make sure that you give that person access to that data. You should keep the data on a secure device. For example, don't leave your data on a pen drive and leave it on your desk and go somewhere. Right? I know spaces. I just walk around, I see on the table there are pen drives, and I can easily just steal it, and the owner will not know what happened to it. And then we will transfer data over the internet or any other network with the deeper secure manner. We'll talk about that later. So these are some of the things we do. Then how do you protect people? We will not really get into that today, but just another thing. And then how can you make sure that you trust the system? Again, we will not go into this in detail today. So how could your system get attacked? Then one is insider. The analysis of a lot of computer security breaches have shown that the majority are caused by actually insiders and not outsiders. Especially people like system administrators, programmers, and people like that are often the people who cause security issues. Then outsiders like associates, former employees, and so on. These are people who are known to you in some way, right? But are not really part of the company right now. And then of course there can be others. Then what are the things which you need to do, or what are the things which you need to ensure to keep your data safe? There are three major things. There are some more, but I will talk about the three major things. First one is confidentiality. Confidentiality says the data is not disclosed to unauthorized parties. So if you have a file and you don't want, let's say, this other person, say Joe or somebody, to read that file, then it should not be possible. Integrity says if there is some data inside the file or database or some other place, it does not suddenly change without the knowledge of the person responsible. And also, if there is any change, then we know who has done it. So, I mean, if you take a database, very often the database may be changed thousands of times a day. But so obviously, the integrity doesn't mean that it is never changed. It means that it is changed in a proper way, and we know who it is who changed it, and that we make sure that it is done in the proper manner. Then the third major thing we need is availability. That is, the data should be available when we want to use it. We don't want the data to be not available. So if somebody wants to use your file and the file is missing, or somehow that device cannot be accessed, it is sometimes called a DOS or a denial of service attack, then see that data is of no use. So these are the three things we should look at when we try to keep our data secure: confidentiality, integrity, and availability, and there can be some others as well. So now let's look at this term for cryptography. Let us බලමු මේ cryptography නැත්නම් ගුප්ත ලේඛනය කියන්නේ මොකක්ද කියලා. Cryptography is to encode your data. You change the data into something so that outsiders cannot actually see what is in the data. This is the only practical way of protecting data which is going across a public network. And you can have confidentiality and integrity using cryptography, and you can have also authentication, which will be explained in a moment. But availability cannot be guaranteed using cryptography. So if you want the data to be available, you cannot use cryptography to ensure availability. Of course, maybe some availability techniques will use some kind of cryptography as well, but let's not worry about that. So let's look at what it is. So all others, so when you have an encrypted file, if you don't have the correct key to access that file, it will look like gibberish. Right? You cannot read it, it's just nonsense. But why do you want to use cryptography? Do you want to use cryptography for anything and everything? And of course, I think the answer would be no. Cryptography is not needed if the data is physically secure. If you can keep the data inside a physically secure device, then of course there is no need for cryptography. So cryptography is mostly or most used when the data is going across a network which you don't have any control over, or maybe on a device which you don't have any control over. Then in addition to the physical physical security, you can have your operating system, your Windows, your Android, whatever it is, secure the data and make sure that it can be read. However, data traversed to public networks like the internet or many other networks is not secure, and unauthorized person can look at the data. Right? So you need to encrypt it. So for example, a Wi-Fi network. Anybody in the vicinity can get this Wi-Fi signal even outside your organization. So if you have a Wi-Fi network in your company, the people outside on the road can see your Wi-Fi network and they can see all the data going on. If you have encrypted the network, then they cannot see what the data is. They can see there is some data, they cannot see what it is. But if you have not encrypted the Wi-Fi network, then anybody who comes by can see exactly what you are sending on the network. And the same is true if you are going using other networks. So this is the model of encryption. There is sender, a receiver, and a communication channel. And we see there may be an interceptor or an intruder who tries to access this data as it is going through the communication channel. And there can be two major types of attacks. Passive attacks are attacks which look at the data but don't try to change it. Active attacks actually change the data, so they can delete data, they can add data, they can change data which is going on the network. And these are very dangerous because if I send A, the attacker can remove the A and send the B. And the receiver will think that I have sent the A, whatever A is. Right? So all of these can be done if you have an active attacker. So how does encryption work? There are two things. One is called conventional encryption, and there what you do is you take the text and convert into something else. So one of the very old techniques, sometimes it's called Caesar cipher, because it was apparently first done by Julius Caesar, which may or may not be true, but anyway, take all the letters in the alphabet, and for each letter is substitute a different letter. So for example, if I want to send the message, send me money, instead of send me money, I send this message LTFR, DP, DAG, whatever it is, right? And the other person can take it and convert it back. For example, if I send this other message, UGGR, DGKA, that can be decrypted as good word. Then the other one is called transposition cipher, where you move the letters around. You don't change the letter, the same letter. So this one send me money. If you look carefully, you will see that the same letters are there, but they are in a different order. That is called transposition cipher or code or encryption. And all of these encryption methods are based on some combination of this substitution and translation, but they can be much more complicated than I have shown. I just give you this as a very simple example. Now, let's say we have very complicated encryption method. And if the enemy or the attacker knows what method they are using, then of course he can use the same method to decrypt it. So, we have to keep the method of encryption secret. But actually, the actual encryption algorithm, the security thing has to be given to many people because everybody should be able to send and receive these things. So you cannot really keep it secret. Maybe for military, they might try, but even military, they know that they can't really do it forever. somebody can always capture one of those devices and therefore get secure encryption. So the secrecy cannot be in the actual algorithm. Instead, we have a key which is just a number, and that number is used to change this algorithm in a certain way so that without the key nobody can find out what the message was. Right? So the key must be kept secret. So this conventional cryptography, also sometimes called secret key cryptography, because the key has to be kept secret. So this is a small picture of that. We have a key, say, which you can see on top, and then we have the message coming from the left, and then the ciphertext or the encrypted message coming in the middle, and then the same key is used on the right hand side, and you get the same message back. And so if you want your thing to be secure, you should have a long key, and these days people are expecting something like 128 bit key as the minimum length for your key. Then about 50 years ago, a new kind of encryption came called public key encryption, which actually uses two keys called the private key and public key. And I will not try to explain this in detail, but basically, you have a plain text, you can use the public key or the private key and get the ciphertext. And for the decryption, you take the opposite of that. If you encrypt it with the private key, you can decrypt with the public key and vice versa. Again, I will not try to explain the details. If you want, there are plenty of tutorials, YouTube videos, and so on, which explain how this works. And you can provide both privacy or confidentiality and integrity using this public key encryption. Now, there is also something called a key certificate. Again, I won't try to get into too much detail, so I will not try to go into too much detail about what these key certificates are. But they allow you to send somebody your public key with a certificate saying that it is correct. So it is like somebody says, I have a degree from something, Manchester University or something, right? And so you might ask, do you have a certificate saying that you have this degree? So they have to bring that certificate and show you. And until they bring the certificate, you will not believe that they have the degree. So the certificate is something similar to that. If you have a key, you should also provide a certificate which proves that the key belongs to you and not to somebody else. Right. So, what are the applications or encryption systems that we use often? We have application layer security, which allows applications to maybe I will keep it. And then we have transport layer, application layer security. At the application itself, we can encrypt data. So one very good example is if you are using Microsoft Word or say an OpenOffice, whatever, and you want to send the file to somebody, but you don't want to other people to see that. You can encrypt that file. Right? Almost all these Office applications allow you to encrypt the file, and then you can send the encrypted file, and separately, maybe by WhatsApp or whatever, you send the encryption key. And the other person can decrypt. That is called application level security. Then you can have what is called transport layer security, which is called TLS and sometimes also known as SSL. This encrypts traffic between the client and the server, and this is what we often use on the web using HTTPS. So if you see a HTTPS on a website, that means it is using transport layer security or TLS, which means all the data going between your computer and that server, and of course from that server back to your computer, is being encrypted. And one good thing about TLS is that from a client point of view, you have a PC or a phone, other than just, well, I mean, all the operating systems by default support transport layer security. So you don't have to do anything except make sure that the connection has been made secure using HTTPS, and then that padlock icon or whatever icon you get is there to show that your connection is secure. Of course, unfortunately, most people don't even bother to check or even if the computer just makes them fast and says there is some problem, they say they basically go and disregard that. Then there are others like IP security, IP security and link layer security, which I will not talk about. They have other layers. Then we can also have virtual private networks or VPN, which allow us to connect from our machine to some other network by completely encrypting all the data which is going across that network. I will talk about that a little more. Then we have digital signatures which confirm the integrity of authenticity of a message. So this digital signatures also uses encryption of cryptographic technique, but instead of secrecy, instead of putting confidentiality by encrypting all the data, what they do is they sign the message using something called a message digest and a message signature. And using generally a public key, and there are many techniques, but the most common one uses a public key, which allows us to check to see if the message I am sending or the file or whatever I am sending is actually sent by that person or is actually encrypted by that person. Now this is very powerful, and in fact I would recommend, in fact maybe later we can have a separate session entirely on digital signature. I really recommend that even more than encrypting messages, encrypting files, if you are sending a message to somebody, if you are sending like an important thing, you always sign it using digital signature. And one easy way of doing that is by using Adobe Acrobat, which has digital signatures built in, and there are many other techniques. Some are free, some are just pay for, which allow you to digital sign messages. There is things from Microsoft Office also. So if you have like a Microsoft Word document, you can also sign it so that when you send to your other site, they can verify that it is not only the same message you sent and are not being shared, but in addition to that, they can verify it has been sent by you and not by some other person, or it has been signed by you and not some other person. And to do this, the receiver needs to get the sender's public key, and that is generally done using a certificate. Again, I will not go into details today because of the lack of time, but we will look at that later. Right. Then I said there are several types of ways in which you can or several places where you want to keep your data secure. First one is stored data. Data that you have stored somewhere. Let's say on your PC or on your USB or on external hard drive or anything like that. What are the ways you can secure that? One is you can encrypt the entire disk. So all operating systems or most common operating systems allow you to encrypt the entire hard disk so that when if you want to use the disk, you have to type in a password or maybe some key management system will handle that for you before you can use it. If somebody steals your hard disk or your USB drive, which is even more likely, they will not be able to read any of the data. Then a second method is file encryption, where you can encrypt the individual file, as I mentioned, using something like Microsoft Word, or there are techniques where you can encrypt any file. Right? There are tools where you can give a file, you will encrypt that file, and doesn't matter if it is Word or PDF or anything else, and you can keep that file somewhere and nobody can read it. So that way you don't have to encrypt your entire disk, you can encrypt only a file. Right? And again, as I said earlier, it is encrypted with a key, often it's a secret key or what is sometimes called a conventional key. And if you lose the key, that's right. So in fact, when you try to encrypt the data using, I think, password, it's a complaint, not complaint, it warns you that please don't forget the key, because if you forget the key, it cannot be recovered. So you have to, whenever you encrypt any data, you have to make sure the key is not forgotten. You can write it down if you like, although that's a good idea. But of course, it's better to write it down than to forget it. So I would maybe recommend that you write it down, but keep it in a very, very safe place. But there are also key management systems which allow you to manage keys, and one very common key management system is in your browser, in your Chrome, in your Firefox, or whatever the browser you are using. Today, they all have key management systems which allow you to manage all the keys or passwords or whatever it is that you use to access various areas websites. Then I think this one, sorry, I had already had a slide on that, so I will not go through it again, but I will just do that. Now, what are the drawbacks of encryption? Now, encryption is a good thing, or cryptography, and using it. One problem with encryption is that there is a lot of overhead. Every single byte which goes through your system, if you want it to be encrypted, it must go through quite a complicated algorithm. And especially on a small device like a phone with a small battery, it might cause significant overhead and might cause a battery to drain much faster than if you don't use encryption. And the speed may be less. Then it is difficult to keep copies of these files. Here, for example, if you download a video and it is encrypted, your computer can't keep a copy of it. It can keep a copy, but it will be no use because without that key, it cannot be used again. So you might find that you keep on downloading the same content again and again because it comes with different keys. Then key management of keeping track of all your keys and trying to remember. Now, would anybody like to who here says I can remember all the passwords I'm currently using? Right? Who here says I can remember all the passwords I'm using at the moment for connecting to this one, that one, Amazon, and Google, and Facebook, and my office computers, and the other office computer, and my friends, whatever thing, and all those. Can you remember all those passwords? And I think the answer is no. So you can use a browser-based key management system, like on Chrome, to keep track of it, or there are others. I will not go into details. But even with these tools, key management is not such an easy thing, right? It is very easy to lose your key and then you have a problem. You cannot use your data, you cannot access your system, you cannot get into your banking system. You try the key 3 times and then or the password 3 times, and then it locks the system, and then you have to run around writing letters and going to the bank and getting enable it and keep this at time. So these are some of the drawbacks of encryption. Also, if you encrypt data, it is difficult to share because either you have to give each of their recipients the copy of your key, or you can use public key encryption and send them a certificate with your public key, but it is more complicated. So I would like to ask you, who of you uses encrypted email? Right? When you send email, do you encrypt your messages? Do you encrypt your email? I think the answer is clearly no, because encrypted email has been available for the last, I think, 20 or 30, I don't know, long time. It's been available for a long time, and it's not very difficult to actually use, but no one uses it because if you send a message and your recipient does not know how to read encrypted mail, they will get confused and they will not know what to do. Or that they will bother you and then you have to waste your time. So encrypted email, although it has been there, the software is there, all the systems are there, everything is perfect, everything is secure, but it's not used. Mainly because it is difficult to use and key management is very difficult and it's difficult. So you do not have encrypted email as a way of sharing. In fact, there is no real easy to use and commonly used way of sending encrypted files. Most people just encrypt the file and send the password by SMS or something like that. There is no real common way of doing it in a proper manner. So these are some of the drawbacks of encryption. And so what can we do? We should try to look at some of things. So let's now focus on problems specifically with transport layer security or HTTPS. Now, many people think that when you have HTTPS, my data is encrypted and everything is perfect. In fact, I think this is one of the main things which society is trying to popularize using HTTPS. Fine. But what we do not push is it is a very, very limited solution. It only encrypts data in transit from your computer to some place on the other side, and you don't really know what place on the other side. And in some cases, especially in corporate networks, they don't let you encrypt data in your computer. You have to send it to some encryption device on your company's network, and they will encrypt it for you. The reason is they don't want you to send all the company secrets by sending it through a TLS or a encrypted channel, right? If you send something on encrypted channel, the company has no idea what they are sending. So they make sure that they check everything you are sending and also the other direction. If you are receiving files, they have no idea whether it is some kind of malware, some kind of virus, some kind of problematic thing. So they check what it is, and to do that, they need to decrypt the data and then check. So many companies, especially large companies, have this thing that the TLS is there, but it is enabled only at the company gateway. And sometimes you may not be even aware of that because they have special techniques for doing that. And on both sides of the connection, on your computer and on the other side, it is not encrypted. So TLS only encrypts from here to there, not on this side, not on that side. So you must then trust both the local and the remote systems with all your data. Now the question is, if you are connected to Google and sending mail through Gmail, do you trust Google? The question is, what do you trust Google with? If you trust Google not to read your data, your messages, then of course you are mistaken. Right? Google will always read every single message that you send on Gmail. I assume you are aware of it, being an Internet Society member. But if not, I will tell you. If you trust Google to do certain things, it's certainly valid. But if you happen to trust Google not to read any message that you send on Gmail or receive on Gmail or anything else, you are they do read every single message which comes to Gmail and many other things also. Then do you trust your own phone or computer? Do you know that there is no malware on your phone which reads the file and maybe sends it to someone else? You don't know, right? So you have to be a bit careful because so many things can be happening. So this is one problem. TLS is a very good thing. It encrypts data going from your device to the other side. But there are many things it does not handle. So if people trying to equate security with the padlock icon and transport layer security are sadly mistaken, right? Transport layer security does not really secure very much, right? It does not secure very much. So just give me a second, I want to switch on the light. Okay, right. Here. Then let's continue. Will encryption solve all your problems? So encryption is a good thing. I have no objection to that, but it will not solve all your problems. As I said, it typically only secures data in transit, and people could break the cryptographic key. It is difficult, but can be done. There can be so many things like spoofing. For example, if you want to go and look at this first uh, domain name I have given, you will sort of at first sight thinking it's spoofing, but it's not. Then if you want to go to the second domain,
එක දවසක්වත් හම්බෙලා නැහැ. එහෙම දැකලවත් නැහැ.
but no, it
මේ
is
හිස්
something else.
පෙට්ටියක් තියෙනවා.
Then there are things called man-in-the-middle letter. If you can guess your password, if you can do social engineering like this amongst assistants, like I mentioned, they can call somebody and tell them, tell them Komari and get some information out of them. So the thing is, encryption is good, but you should not use it all the time, and you should not think that okay, encryption is needed for it. So data is not critical, right? Then you do not need to use encryption. If you don't trust the remote site, right, there is no point encrypting the data and send it to place it is not trusted. And most sites, remote sites, I would not trust. So I don't know why you would bother to encrypt data and to a site you don't trust. And if you need to share data with many people, you would not use encryption. So there are certain reasons, but mostly I feel encryption is a good idea, but think of it not as a solution to every problem, but small part of the solution of security. So in conclusion, information security is important, and you should, if you are using any kind of IT system, information system, think about security. Cryptography is important and it can secure data in storage, at rest, and other places, but it's not enough. And we should not believe that just because you have HTTPS running or something like that, that you have security more. There is many more things to do which means if you want to make sure your systems are secure. Thank you very much, and I believe we can go on to the next part of the discussion.
All right. So thank you, Professor Gihan. Yeah. So do you have any questions for Professor Gihan? So before we move into our next session, so you can use your chat or you can ask question. You can unmute your microphone and ask. I can give you a few minutes.
I seem to be having a problem with the speaker, so this means
All right. So I think so we can jump into the next session. So if you have any question, follow-up question, you can email Professor Gihan. So he puts his email address.
if you want to ask any question, you can ask me now.
Yeah.
Okay, I don't hear anybody. Is there anybody on chat?
Okay. All right then. Yeah. So thanks, Professor Gihan, for this detailed information about encryption. You know how it the technology it's used. And now let's go to our next speaker. Next speaker is Dr. Lakmal Rupasinghe. So he will be talking about blockchain security. And so over to you, Doctor.
Yeah, thank you. Am I audible enough, Prasad?
Yes, yeah.
Yeah,
Yeah.
that's good. I can share the screen, but I think Professor Gihan needs to unshare. Okay, that's fine. No, still I don't have this share permission.
How now?
Yeah, it's all good. Thank you. Yeah, So I believe you all can see my screen.
Yes.
Yeah, perfect. Thank you, guys. First of all, let me thank ISOC, President Pooja, Ani Prasad, and the team to invite me. And of course, it's a very interesting discussion. Let me start. When I wanted really to find the topic, I really went into the mission of ISOC. Probably, I think most of you are members of ISOC. But anyway, just wanted to show that these are the mission and mission statement. And obviously, we all use the internet, and internet makes our lives much better. So as it says, advancing development application of the internet infrastructure, technologies, and open standards. So this is like, as an example, whatever the technology we use, the YouTube or the internet itself, or the HTTP, or whatever the technology we use, it makes our lives better. So I was just thinking, okay, what are the next technologies down in the line that we can make ourselves, make our lives better, and probably make our country better, right? So I was thinking in that line. So what reminded me, there were a few technologies, and one technology was blockchain. I realized because this event is on encryption, so blockchain is everything about encryption, right? So then I wanted to search a little bit about encryption, and what encryption brings us is obviously security. I don't want to talk about, because Professor Gihan had touched on that. And of course, the other term that and we all should be looking for is the term called trust. Because if you go beyond security, of course, we all need security. When you take a call, when you send a message to someone, when you receive an email, you need information security. So we all know that, and you all know the basics of encryption. But we need to now go beyond encryption and need to understand the principle of trust. So we have seen cases of the base idea of trust was broken. And this was, of course, evidently even very recently of what happened to Sri Lankan rupee, the dollar, and even this is happening in many other places, right? So I'm not going to talk too much about it, but the answer for that also comes with proper encryption. That one of the good solutions which was built using encryption is blockchain. So we are going to talk about it, talk about blockchain, and how blockchain can get value to all of you, whoever here, or even to our country, and obviously generally for the whole wide world. So that's what I really want to talk about, but will be very specific on the topic of blockchain. So we'll jump in, and then I really search for this particular graphic, which I found, blockchain technology market size. Because these days we need to learn things which probably would revolutionize the world. It will be much better, I believe. So if you carefully look at this graph, you can see, just want to double check, am I audible enough, guys? And Prasad and can see, I believe, my share.
Yes,
Just
yeah.
Yeah,
You're clear. Yeah.
Yeah, thank you. So you can see now we are in 2022. I think this is real value. Billions of dollars, right? Dollars in billions. So it's almost $12 billion. That's the market size of blockchain. And they are predicting it will grow in multiple folds up to $162 billion in few years. So that's going to be one of the biggest industries in the world. So we'll see why, and we'll see what is the opportunity for you guys. Right. So let's jump in. I'm going to close this. The pages quickly, and just want to show you this as well. I'll come to this probably at the end of the session. So we are a developing country. So why developing nations should embrace blockchain? So that part I'll come probably at the latter stage of my presentation. So I'm not going to go through any of those things now, but if you want, you can keep a track on this article from, I think this is ACMS today. Right, anyway. So let's look at some very specifics as individuals, why you should work out blockchain and you should study about blockchain. And of course, my topic is blockchain security and smart contract security. That does mean there are some problems with blockchain. So what are those problems, and where is your potential opportunity. So before you go there, I'll go to this site. Some of you probably have seen this. This is a place where you can do these things called bug bounties. People who never heard about bug bounties, I'm going to talk about things which are lucrative, but the whole point is not to show something and make yourself attracted to it. That's not the point, guys. It's all about showing that there's a potential opportunity here. So this hackerone.com, if you've never been there, it's called a bug bounty site. It's basically where if you have big companies where they have problems in their systems, including web or mobile, they will lose a lot of money. As an example, recently, if you can remember, Uber was hacked and they lost a lot of money due to that. And LinkedIn was hacked. And likewise, there were so much of issues. And most of the time, yes, it's basically issues with security, encryption, and things like that. So what they do is they register with these organizations. And what they do is they will ask people like you and me who uses the internet with some knowledge to come and hack them legally. And they will pay things called bounties, right? So this is such an organization. And I'm always showing this to my students as well. So there's this guy called, he's William from Australia. And this is his income from bug bounty. So simply saying again, what they do is they go and, so in this particular instance, he has gone to GitLab. I think you all know GitLab, like GitHub. So there are some mistakes or security vulnerabilities in GitLab. So what they do there is they go and analyze as an individual and report it to GitLab through this system called HackerOne. And then if that vulnerability is a real one, they will pay. And we have done some calculations very recently in one of my classes. This guy had almost earned $250,000, right? $250,000 within 1 year. That is last year. So that's a lot of money, guys. $250,000 by just doing this, not a job, just like submitted some reports. Right? So $250,000. So you do the math and see that how much it's from Sri Lankan rupees. Anyway, I just don't want to show you these lucrative things. It's not the point. So I'll quickly move on. So this is called bug bounty for Web 2.0. Now I'm moving to Web 3.0, which is the blockchain. I'll come to blockchain, but just wanted to show where is the opportunity. So I'm going to close this. Hope you understood the idea. So if you go and check this one, you can get the recording later. If you go to this link, you can find out how much he had earned, all big amounts. Right. So let me close this. Anytime if you have questions, stop me and ask. I think I have almost like 1.5 hours, but let me try to finish as soon as possible. But anyway, let me go to the next site, which is code for, I think code for Arena or code for Arena or something like that, right? So here, this particular organization, so they say C4 audits contest find more bugs faster than any other method. So they are a very similar organization like HackerOne, but their main objective is to audit or find vulnerabilities in blockchain. So now still some of you probably not know what is blockchain. Please be a little bit, just wait for a few more minutes. I'll come to that. So there are a lot of issues in the blockchain. Now, you might wonder what is blockchain and is it really there? Yes. All these things called, probably I've heard about cryptocurrencies like Bitcoin, Ethereum, all are hosted on blockchain. And there are so many other things hosted on blockchain. And you know, they say cryptocurrencies are better. But the thing is, even those things can be hacked. So now you need to understand, okay, that can be a bigger issue because now I showed you blockchain is going to be a huge industry, right? And if these things can get hacked, that will be a problem. So these organizations runs these bug bounty programs for everyday people like you and me, not only people who have done probably a PhD, no, or probably have 20 years of experience in this, no, right? Anybody can learn these concepts and can find out vulnerabilities in the blockchain and can find and probably earn money. Now, you can see these are really big amounts. See, this is 100,000 USD, right? And this is, you can go to this contest. This runs as contests or simple challenges. You can go there and find out the issues and you can submit to them. and then you can probably earn this amount. So similarly, you can see all big amounts starting $75,000, $50,000, huge amounts. So I'm not going to go through all of them right now because you might not understand really what are them. We'll learn blockchain and come back to these things as well. And similarly, this is another such organization. And as you can read here, they are saying, so they're talking about Web3, which is the blockchain, leading bug bounty platform, protecting $100 billion. That is probably 20 times the GDP of Sri Lanka, right? I don't know if that's right or wrong, but I believe so, right? So it's 20 times the GDP of Sri Lanka, right? Anyway, not GDP, maybe the yearly spending. Please correct me if I'm wrong. Anyway, so they have already spent around 60 million bounties already, and you can see the rest of it, right? And of course, if you go down, you can see they're paying again 1 million. Is it 1 million or 10 million? I'm not really sure. For an organization. So if you go and look at this bounty, what you're supposed to do here, we'll come to this again to understand this concept called smart contracts. And then you have to find out vulnerabilities of this smart contract. Right. Okay, I'll stop from there. So let me summarize. So up to this point, what I tried to explain was, okay, there is a great opportunity. Now, there are some technologies coming into the future, as an example, quantum cryptography, right? Quantum physics and quantum biology. So there's this new term called quantum coming in. That's going to be a huge industry, right? And of course, machine learning, deep learning, these industries, and also cybersecurity. There are areas of cybersecurity which obviously huge, where we can earn billions of dollars to a country like ours. And then I picked blockchain because it totally tried to solve the issue of trust or security using encryption, what Professor Gihan touched in the first session, right? So in the Global Encryption Day, this is something that we need to talk about, right? So now we pick blockchain, and I'm just showing you one of the great opportunities that you all are having, which is to do this thing called finding vulnerabilities in blockchain. That's why I named my topic as blockchain security. And then as the secondary one, smart contract security and auditing. So we'll understand what is it clearly. Right, guys. Any questions up to this point? Because this is a bit of a bigger scope, so I wanted to make sure that everybody are in the same page. Hope things are clear. I'll take a 30-second break just to make sure that things are all right. Okay, so let's move into the second topic, that is to understand what is blockchain and what problem it solves. Okay, let's try to understand. I don't know how many of you heard about the McDonald's scam. It's McDonald's, right? McDonald's, or maybe should be McDonald's scam. It was in 1980s, maybe. Yeah, this one, right? So how the Macmillan scammers rigged McDonald's monopoly game and stole $24 million. So the whole idea was McDonald's, they came up with a sort of a lottery sort of a thing with the game called Monopoly. I'm not going to go details on it, but there's this big company, McDonald's, everybody loves, everybody trusts, right? Then what happened at one point, there were people inside who scammed the whole thing, right? So this is where we need to understand the concept of a contract. As an example, when two people marry, there's a contract. If you break the contract, you obviously can't be married, so you're going to get a divorce. So contracts are very important. But the problem is, when we go for contracts, there are humans involved, and humans are always are untrustworthy, right? So this is what happened in the McDonald's case. You guys can read this. I'll probably share this in the chat. You can get a copy of this article, which is one of the best articles to read. Let me quickly share that. Right. So this was a case, a big company. So that's the internal issue, but somehow they basically broke the contract. So we cannot trust the contract, right? So the idea is, how can we create a contract that is trustworthy, where humans are not involved, that is immutable. We say it's immutable, not mutable, that you can't change it. So as an example, this is a problem with the currency. our Sri Lankan currency, it's not immutable, it's mutable due to some human error. Now it is going up and up. Similar thing happening in USD. The USD same issue was there in 2008, if you can remember the financial meltdown. So similarly, if you go and go to a big company, say even Microsoft, right? They say they always secure our data. Maybe they cannot be trustworthy all the time. So I know you all know about, or probably some of you know about have by being pwned, right? If you go here, you can check your email and see whether it's available in a memory dump, or sorry, kind of a dump which are pwned. Pwned means like a company got hacked, and you, because you have a email registered or a username registered there, your information is outside. So as an example, if you go and check, all these companies was hacked. So their contract to secure us was broken. So how can you trust them? Right? So DataCamp was hacked, and of course Dropbox was hacked in 2012, and of course Microsoft LinkedIn is owned by Microsoft. 2016 it was hacked, and again 2021 it was hacked. So the contract was broken. So this is the problem. So if you have an insurance agent, they have a contract, but anytime they can say, no, we are not going to pay you because we are out of the business. So how can you trust? I hope that you understand that. So the blockchain solves that problem. Right? Still, you don't know what is a blockchain, but remember, blockchain solves that problem to a great extent. Right? So again, what is the problem? We can't trust the contracts created by Sri Lankan government or United States government or maybe United Nations. They create contracts, but we cannot 100% trust them. If we have good people in those seats, yes. But what if there are scammers, like in the case of McDonald's? So we cannot trust the system. We cannot trust these contracts. So that is where we build something called a smart contract using this principle called blockchain. We learn blockchain, and it's the case where Satoshi Nakamoto, probably you guys have heard about this pseudonym, Satoshi Nakamoto, let me search, wrote a paper in 2008 and introduced a concept called peer-to-peer electronic cash system. That time, blockchain was there. It was a thing. It was a thought experiment, like Einstein did long time back. He also did a lot of thought experiments. This was a thought experiment. There was no blockchain implemented at this time. So we still don't know who's this guy or who's this organization or whatever. Maybe aliens. We don't know, right? And Satoshi Nakamoto, this person or maybe aliens, wrote a paper saying we can use the concept of blockchain and create a decentralized, another term, peer-to-peer, decentralized peer-to-peer system where we can trust. So, and he mentioned, or they mentioned, whoever mentioned, there's a concept called proof of work, right? And we can make sure that system can be 100% trusted, because there is a code called a contract, or called a smart contract, which is embedded into the blockchain, which no one can mute, or it's completely immutable. So now we have a system where basically 100% trustworthy, because there's no humans involved. It's completely automated, like a robot, right? So that is the base of blockchain. So don't get it confused. Cryptocurrency, or this idea called Bitcoin, is an example for a blockchain. Bitcoin is a blockchain, but blockchain is not Bitcoin. So understand that. Because blockchain can be many other. So we'll go there. Understand that. Blockchain is like a database. It's called a decentralized database. We'll simulate it and see. We'll do a practical for this. Right? So Bitcoin is an example for a great blockchain. So this is called the first cryptocurrency. The word crypto is all about encryption. But Julius Caesar started, like Professor Gihan mentioned, had grown up to something universal, right? So if you want to learn about cryptocurrencies, read about entropy from Shannon, one of the greatest scientists, and learn about how this information theory helped in understanding randomness and understanding of even going up to things like RSA, right? So that's the history of encryption and cryptography. We are not going to talk too much about it. And understand this cryptocurrency means because this particular blockchain, example blockchain, uses crypto or encryption. Right. So now give me another example. Can someone tell me another example of a blockchain? You probably have heard about it, no? Without knowing what is a blockchain. Give me another good example for blockchain. Can someone please tell me? I see Shiva is here. So Shiva, can you give me an example? Anyone?
Someone
Now
says
the
NFT.
medical industry, that means
Yes.
that according to HIPAA, every medical industries in the Europe and the US, all the countries, they are moving to the blockchain to store the medical history records.
Yeah, thank you so much. Yeah, somebody said medical. Yes, Shiva said medical information. And also somebody said NFT, right? And of course, legal contracts. I'll go there. But probably most of you know OpenSea. And probably most of you have seen CryptoKitties, right? CryptoKitties, right? That is kind of, or CryptoPunks, probably something that revolutionized the whole world. But if you go to CryptoKitties, some of you might think, is this a joke? No, it's not a joke, truly, guys. It's not a joke. Yes, there are pictures of cats, right? So let me go to the catalog. Pictures of cats are sold at sometimes millions of rupees. So now if you go and get one of those kittens, right? Why this is happening? Still, I don't know, right? But this is happening, right? So these cat pictures are sold at sometimes millions of rupees, sometimes millions of dollars. Similarly, if you go to this very famous website called OpenSea, you can find, so as an example, if you go here, this particular picture, I'm not sure why, but still, it's, what is it? It's Jenny Human Channel by, I don't know, what is it? But anyway, so this is sold for, in this case, it was sold for 0.04 ethers. So let's find out the value, or let's go there. Here, maybe you can see, the full volume of this full package, or there will be several images here, 112 ethers. So ether is another big, sorry, cryptocurrency to say LKR, right? Like Bitcoin. So it's almost 500,000 rupees. So it's not a joke, right? So these are called NFTs, non-fungible tokens. This is another example of using blockchain. So what they do is they create a copy of this one in a particular blockchain, right? And then they make sure no one can change this. So as an example, if Shiva buy this from OpenSea, no one can change that transaction and no one can deny that transaction. So this is owned by Shiva until it's being paid, or it's being sold to somebody else. So this is the cool thing about blockchain, and this is going like wildfire, and everybody is loving this idea called OpenSea. I'll come to this again. So this is another example of blockchain, right? So let me summarize again. We understood, okay, there's a great concept or technology called blockchain, which is really useful, which uses encryption as its core technology, or cryptography as its core technology. And then we learned few examples of blockchain. Of course, the first one was Bitcoin. And then there are so many other coins, of course, tokens, like crypto tokens or currency tokens. There are plenty of them, including there's a funny one called Dogecoin. If you have time, we'll talk about it. And then, of course, there are so many other examples called OpenSea. And if you go to DeFi, we'll talk about it in a bit later. DeFi is decentralized finance. And there's another one called DAO and many other examples for blockchain. Right, that's where we are now. Now we need to understand, before we understand, okay, how can we earn money as a country by hacking blockchain, to understand what is a blockchain, what is a blockchain, right, guys? So let me go into a quick slide. Okay, let's try to understand what is a blockchain, right? So a blockchain is basically a ledger, right? It's like a distributed database, right? It's a distributed database. And of course, Bitcoin is an example. So now we need to understand how this principle came into being. So in 1991, cryptographically secured chain of blocks. So this idea was there for a long time, right? And even 1998, so this especially researchers in the area of decentralized peer-to-peer world, I think probably have heard about this peer-to-peer networks like torrents. So those principles were there at that time. If you guys can remember, the old people like me, right? So we downloaded movies those days in 2004, 5, 6 using torrents. So that's a peer-to-peer network. So the idea of decentralized or this decentralized parallel work was there for a long number of years. But in 2008, this concept was very popular. Researchers, academic researchers, even some industry-based researchers were working on this. And that's where Satoshi Nakamoto, or this alien, whoever, right, came up with this pretty interesting paper called Bitcoin, or I showed you that paper. And then, you know, this all things happen, right? So the base idea of blockchain is, of course, the most important thing, this is immutable. I'm going to talk about this very technical concept like global singleton pattern. But very important thing, probably, it's non-stoppable, meaning it's immutable, and also it's verifiable. Right, now we'll really look at a blockchain in operation in real simulation. So I'm going to take this great website. Let me quickly share this in, you guys can also do this with me if you want to. This is sort of a workshop mostly. Right. So please, Prasad, let me know if you are taking overtime. So I think we have a little bit of a time yet. We're going to finish around 7:30, I believe.
Yeah.
Anyway, yeah. So you guys can also come here. This great gentleman, this is his site truly, so I need to give full credits to this gentleman. Anders Brownworth, right? You can find a lot of contents from him there. But anyway, so this is his demo on blockchain. Right, now we try to understand stage by stage what is a blockchain. So please concentrate on this section. Right. Before you really understand blockchain, you need to understand what is encryption. So I think Professor Gihan worked on that, touched on that. And one of the coolest things in encryption is a concept called hashing. So hashing is a one-way encryption. So as an example, let me take my prompt. Right. So there are a few hashing algorithms in the world, very famous ones. There's one algorithm called MD5, right? So then I think it should work. So I can give a statement like, I love blockchain. And I can, okay, I think I need to use a separate tag here. Let me check quickly. Not really sure. I think it should be MD5 -- help. Might work. Oops, sorry. I think it should be maybe -s, or maybe I can type in my name here. Yeah, so that will convert itself to a hash. Now, the cool thing about a hash is it's one way. It's like a fruit juice, right? You put few, let me clear this one. And yeah, so I input my name, and then it creates this hexadecimal value, right? It's hexadecimal, yes, yeah. So which is a one-way function like a fruit juice. You can't take back the term Lakmal, but you can always double check whether it's the same thing. So whenever I use the MD5 algorithm, I given the term Lakmal, you'll always get the same hash. That's the universal principle. But if I even change a small thing, it will convert it to a completely different hash value. And this hash principle is one of the core principles of encryption. And it is one of the biggest, I would say, technologies used in blockchain. All right. So I think you understood this one, small demonstration. Same thing here. But here they use as another, probably more practical algorithm called SHA-256. You can search in Google and can get more information about SHA-256, right? And this is used in many algorithms that we use in everyday life. So now let's see what it does. So it have a original hash, and you might wonder how come this hash comes here. Truly speaking, this is the hash for 0 or no data, right? So there's no data here. I believe you all can see this screen. There's no data here. So basically, guys, this is hash for 0. If you input 0 to SHA-256 algorithm, this is what you get. Now I'm going to type in Lakmal. Now see, it's a bit different from what you get from MD5, but the format looks very similar. It's just a value, a hexadecimal value that you get out from this one-way function. Again, if I do a bit of a change, it completely changes its structure, but it's the same length, guys. Remember, right? It's the same length. So this is called a hash. You will understand why this concept of hash is important. So why we use hash, somebody asked? We use for multiple things. Now you download a software from the internet, you given with the hash. Why? You have to, now say as an example, if you download the software, in the middle from the internet, somebody can inject a malware. So the original file changes. So this is this is the software. We'll say this is the original software, right? So assume there are a lot of data here. Now this is the hash one. So when Microsoft gives the hash to us, so what happens? I copy the hash first and I download the software. In the middle, hackers add some bad malware in it. Now it's not the original hash. Now I know it's not the original software. So likewise, there are so many examples or value out of hashes. So please remember this, because this is the core principle we use in blockchain. And technically speaking, we call it as integrity checker, right? We call it as an integrity checker, right? Any question up to this point? You need to understand this to go and understand the rest. Hope it's okay. Right. Now we'll move into the idea of block. Okay. So yeah, so you guys can also do this with me if you want to. So this is a block. So I can create this type of block even in my phone, even in my computer, the computer that you are seeing. I can create a blockchain in my computer. So it's truly there. You have to use some a programming language to do that. So later on, we'll try to see what programming language we can use. So I'm using a language called Solidity, and I need to use a platform also to create. But we all can create. I can create, you can create. All the people who are in, all 43 people can create a blockchain in your computer. Right. So now we have a block. So this is not a chain, it's a block. So what happens? This hash is a little bit different, guys. The difference is, if you guys can see, there are 4 zeros here. Right. Now, the thing is, now try to understand this. Here also it takes a hash. But remember, there are so many inputs, not so many, 3 inputs here. There's a block 1, right? And there's something called a nonce. We'll talk about it later, which I can change if I want to. Okay, right? And then data. So data can be anything. Later on, we'll understand a blockchain. What you have is only transactions. It can be a monetary transaction. It can be a transaction of CryptoPunk, which I'm going to sell here. Likewise, right? So truly, we don't have data like this, I love you or something like that. You don't have such data, but this is just to demonstrate. Now, let me refresh this again. And this is the original block that I had. And the nonce was 72608. Hope that is clear. All right. And the hash is something unique, but it always starts with 4 zeros. Right. Now, for the moment, let's assume something like I love blockchain. All right. Now, what happened? If you can see that color change. So yellow is, sorry, green is always good, no? So this is rosy color. It's sort of bad here. So now there's a button called mining. Probably you've heard about something called blockchain, Bitcoin mining. So now I need to mine. Mining is operation, guys. Nothing else. It's like an algorithm in operation, right? You have to do work. So that's why the term mining is used. You have to hard work, proof of work. So now what is the work that you do? Now the thing is, now the hash had changed. So this seems like not a verifiable hash. We need to have a hash where you have 4 zeros in the beginning. So I need to start working with my nonce. So truly what I'm doing is finding the right nonce. It will take a long time sometimes. If I do it manually with my human intelligence, it will take a long time. Say 2, 3, no, it doesn't work. 6, 7, 8, 9, maybe 10, no, 11, 12. So it doesn't seem to be having any zeros here. It doesn't work. So there's an algorithm works in the background. Let me do the mining. And now let's see what's going to happen. Okay, it took a little bit of a time. This computer is a little bit fast. If you have a quantum computer, it would have done really, really fast. But anyway, you get 4 zeros here. So that process of finding the right nonce, that working with the right data and the right block, that is the process called mining. Hope you can understand that part, right? So the idea is always to get the right hash. So this is called the signing process. Like you use a symmetric key or in RSA keys, private key to sign. This is the signing process. Oh, this is a verifiable process, right? So this is what happens in a block, right? Now we'll move to a blockchain. Again, if you have questions, please ask. I'll move to the blockchain now. So now we are going to create a blockchain. But remember, this is the confusion a lot of people are having. They assume the blockchain is in different peers. No, guys and ladies, right? This blockchain is in a single computer. This is in my computer. For a moment, assume this is in Lakmal's computer. So I am creating this chain of blocks. And why you say it's a chain? How it become a chain? Now this is the thing. So this is called the genesis block. Why? There's no previous hash. It's all 0. And when you come here, there's a previous hash, which is the hash of block 1. So hope you guys can see it. Block 1's hash is this one. And that is the previous hash for block 2. So that's how it becomes a chain. So you get connected, right? And the block 2's current hash is the previous hash of block 3. So likewise, at the moment, there you have 5 blocks. These blocks can, grown into even thousands of blocks. But remember, this is in a single computer. Ideally, it will not be in a computer like mine. It will be in a server sort of. Right. Now, this comes to the point where we have to understand why you are doing something crazy like this. Why we are doing something crazy like that? Why can't you do this in a single computer in a database? We have so many powerful databases, Oracle, SQL. The problem is Oracle SQL databases are centralized. That is the problem. This is going to be a decentralized architecture. But then you can argue, now you said right now this is in a single computer. Just wait for a moment. Right? Just wait for a moment. Be patient. Now in this blockchain, the cool thing is, now for a moment, if I do some changes, now everything seems good because everything is green in color. For a moment, if I do some changes, I can't change the hashes. It's automatically calculated, but I can change the block number or the nonce, or I can add some data. I hate something. Now you can see what happened. This particular block became purple in color, not purple, rosy in color, or say red in color, which is bad. So I have to mine this again, right? I have to mine this again. Let's mine this. Then it becomes again green. So it's fine. So now, this is where we have to understand, because we have hashes to verify, if you do some crazy things like changing something, you can change, right? You can change. There's no problem, guys. You can change. So I can say, I am doing something, say, something bad here, right? Now you can see the whole blockchain becomes mutable, or simply saying, this is now not usable because this has been, say, violated. So now if I want to make it to the correct position, I had to mine everything again. I mine this one, and then let's see what's now. It's taken a long time because it's not that easy. It'll take a long time to mine sometimes. Few minutes maybe, and probably a little bit more time also. Yeah, now it got mined. Now this is back to normal. And again, I had to mine this one. Likewise, you can see if one of the initial blocks were changed, the whole chain had to be mined again. Right? This is one of the complaints of blockchains, because if you do a lot of mining, because to do mining, you have to use computational power. It will, yes, of course, it will take a lot of electricity out of the world. So more electricity means it's not good for the what we call as nature. So we'll not talk about bad things about blockchain right now, because we are going to anyway talk about bad things, cybersecurity or security issues. Right now. Okay, now we know how the blockchain works in your computer. So you can do any changes because you can mine it. But this is not what happens in the real world. In the real world, it's really distributed. This is where the magic happens. So this is your computer. This is Lakmal's computer. So I think I own the blockchain. But guys, it's not how it works. This one gets connected to Prasad's computer. And the same is getting connected to Shiva's computer. And likewise, it's not only 3 peers, ideally it can be thousands of peers. Now, see, I created this blockchain. Now, if you closely look, the third block, now just concentrate on the third block. Let me go and get the third block in my computer. If you carefully look, the previous hash and the hash both are same. So what happens simply, guys, when I created this blockchain, it will get copied to other places. So once it copied, now if I do any changes here, so now see what happens, this is violated. Now, say assume there were several transactions which I did. Now I'm going to do a kind of a wrong thing and say I did the transaction for $20. No, I have done it for $30. Now I did the change to the contract. But the problem is that was not reflected here or here, right? In the other 2 peers, it's the same old one. So now when you look at the agreement or consensus algorithm, or the algorithm who tries to correct this, these peers B and C come and say, you bugger had changed this, but we have the majority saying, no, this record is wrong. And so you cannot do that. Again, please listen. This is the most important point. Peer A, hackers connected or some criminal connected to this blockchain and change it. But the hacker or the criminal don't have access to peer B and C. Assume they have access to peer B, but there will be another 998 if you have 1,000 nodes in that blockchain, right? They will not have the same logic, right? So they will come and say from the majority, this is called a consensus algorithm. A consensus is agreement again, right? They will come and say, no, guys, you can't do that because we know the same values are there in all the other peers. So you can't do this. So this is wrong. So either you have to go out, we are not going to change this transaction, and we are going to keep the same transaction. So this is immutable. This is where we go back again and we ask the question, why this concept called blockchain is there? Because it's trustworthy. Now, government cannot say, no, we changed. The minister cannot come and say, no, I changed the percentages of profits. No, you can't do that. That initial calculation was there in a place called a smart contract. So how come you come and change it now? You can't. It's universal hereafter. Hope that is clear for you guys. So this is how the immutability works and verifiability works, and why blockchain is going to be $1 billion industry. It's already is $1 billion industry, and it's going to be one of the top industries, maybe with oil, maybe with energy, maybe with health, and maybe with machine learning. You know, blockchain is also going to be huge. Right. I'll take probably 1 minute for you guys to ask questions, because this is probably the center point of attraction. So if you don't get this right, you can understand the rest. Any questions? So a blockchain like Ethereum will work on this model. Blockchain like Bitcoin works in this model. Blockchain used in OpenSea, which is NFTs, right? So they probably use Ethereum or something similar, use the same model, same logic. Yes.
Yeah, look, Lakmal, now, so why someone says that, you know, when you do transaction in Bitcoin, you cannot track. So those are used for like...
I'll come to that. I'll come to that. Okay. Yes. You can track any transaction, but almost all transactions are anonymous. I'll come to that. Right. Hope that is... yes. Go ahead.
The block 2 now you are changing, then the integrity is...
violated. Yes.
Violated. So now the block 3, okay, it understand because the block 2's output become as a block 3's input.
They are wrong. So as an example, so this is being violated. So then of course you need to mine this first. And this you can do, like as an example, if this is your node, you can do as a criminal, you can do all this. But the thing is, none of the other peers will agree. They will say, yeah, you can do mining, you can change it, You can make it right. You can make the hashes correct. You can check the integrity. But now what we have is something wrong. Even you mind it. Now see in block 4, my block 4 doesn't have the same. So now carefully look. The previous hash is not the same. The hash is not the same. So this is incorrect. And peer C also comes and say, yeah, peer B, C, and maybe D. If there's a D, they say, yeah, we all have the same. But you, peer A, is now broken the contract. So you cannot be in this blockchain anymore. This transaction is void. Is that clear, Shiva?
Yes, sir.
Yep. So now let's go to the next one, and we look at a real blockchain in operation. So like I told you, there's no something called data here, like I love you. What you have is tokens in operation. This is example of a cryptocurrency, but totally what you have is transactions, guys. So sorry about it. So let's quickly finish this up. So what you have here is, say, Darcy did the transaction to Bingley with $25. So this is the first block. So these are different transactions in different blocks. Try to understand this. Assume for a moment this is Bitcoin. And again, Elizabeth did the transaction to Jane. But in the real world, guys, you don't have names like this. What you have is just another hash to uniquely identify you. I'll explain how it works in a bit, right? As an example, if you need to do or create a Bitcoin wallet or address for Bitcoin or Ethereum, I'll tell you how to do it. It's not a big deal, right? Right. So now in this block, what you have is 25 Darcy to Bingley, $4 Elizabeth to Jane. Truly, this should be Ethereum or Bitcoin, but yeah, this is just example. And see, you can see do that. And same is copied everywhere. So this is like truly like a very true Bitcoin, a realistic blockchain, right? And now here, if I change, this is what the people are doing. So Hicks or Newton, right? So Newton is a criminal. He want to get not $10 from Hicks. He want to get $1,000. So he did it. Somehow he managed to change it and mined it. And then he didn't ended up mining only this particular block. He mined the third block and the fourth block and everything. And he come and say, okay, I want that money. But now see, even after mining, the block 2 in peer B still says Hicks sent Newton only $10. Oh my God, what is that? So I'll just wait, right? Yeah, it worked out. So this $1,000 is only in this particular peer. Oh good. It's not going to work. Peer B says, no, that's incorrect. Peer C, you can see the transaction, it's incorrect. I hope it is clear. Are you all clear about this? I hope it's clear. Right. So you can see it's all hashes, encryption in operation. So totally the base concept of blockchain, whether it's cryptocurrency or NFT or DAO or any other, every time it will be a transaction works with hashes. So now we look into a real set of transaction on a real blockchain or truly set of wallets called Coinbase. I think probably you all know or probably heard about Coinbase. So this is a real set of transactions from Coinbase. But remember, only thing is you will not find the names. So it's a very similar thing. You guys can have a look at it. But now I have almost explained what is a blockchain. So again, quickly summarizing, the base concept is hashing. Using the hash, you verify a block. And by connecting several blocks in one single node, so guys, this can be in a single server, a big server farm, right? And similarly, to get the real work done, you create a distributed ledger, right? So the whole concept works when you have so many people into this only. Please understand that. Otherwise, it will not work. It will not work. Right. Any questions? So now we have understood the base principle of blockchain. Anything that you want to clarify?
Dr. Lakmal, now, so I heard that recently Bitcoin get hacked, right? And then now what happened, like if a hacker can attack not only peer A, like peer B, and is there a way that we can?
Yes, very good question. That is the question that everybody asks. But the problem is, we say deterministically, it's very difficult when you have 1,000 nodes to hack all 1,000 nodes. So that is the real reason where blockchain cannot be hacked ever, right?
So like, can hacker knows like how many blockchains are there, for example?
You can, of course you can, but you can never hack it. So because the way how it is structured, you cannot hack all the peers in the blockchain. Of course, there's a possibility of doing that, but it's very highly unlikely. That's why they say it's secure and trustworthy. Yeah. Anyway, good question. You can talk about it, and researchers works on all these problems every day. Not only academic researchers like us, but there are so many other people who are working on this. All right, guys, let's move on. So I'm going to close this one for the moment. Now we'll go to Blockchain Explorer and try to see what are those real blockchains implemented, and are they really there? So those are the questions that we'll have. Yes, all of them are there. And the most important thing is any transaction happen in a public blockchain. There are two different types of blockchains. There are private blockchains as well. We'll talk about it if we have time. One single organization can do that, but at one point they will make it public. And most of the blockchains that we are talking about right now, they are public. Right? So as an example, Bitcoin is a public blockchain, Ethereum is a public blockchain, Solana is a public blockchain, and there are so many other similar blockchains. So as an example, if you go to this blockchainexplorer.com, what you are seeing is all the transactions that's happening in the world right now at this particular moment, and you can even go back to 20 years back in the history and you can find any of those. Now what you're seeing here is, see, the transactions that had happened, 260,000 transactions, and today they had done probably few billions, isn't it? You can do the math. And hash rate, we'll not talk about all these technical things. The blockchain size is 433 GB. And I'm not going to talk about all these things, but you can see at the right hand side some blockchains and some cryptocurrencies. But remember, these are two different things, right? Mostly these are blockchains, and then these are the transactions. Let me go and see some real transactions that's happening, right? So now what we are looking at is set of transactions, but they are called unconfirmed transaction from Bitcoin Explorer. All these are Bitcoins in operation. Now, have you seen this transaction? See, there's a huge transaction, 245 Bitcoin. I don't know who, you can't ever know who, but let's go and have a look at it. So there's a big one here. That was almost for, let me capture, it's very difficult to capture, but let's see. Right. So this particular
14,000.
Yeah, so I think I clicked on the wrong one. Let me click on a bigger one, obviously. Okay, there's one for 66,000, was it? Okay, I can click on this. So what I'm clicking is the hash. So this is the hash, guys. See, this is the hash. Right? If you want, you can take this out. And so then we have few other information. So of course, this is 3 Bitcoins. That's a lot of money, guys. That's a lot of money. Right? But it's an unconfirmed one yet because everybody is mining at this particular moment. Because Bitcoin network is pretty large, right? And you can find few other details, the hash for that particular transaction. So every transaction that happens in a blockchain, whether it's a crypto related or whether it's completely otherwise, say as an example, OpenSea, this one, this is not cryptocurrency, right? This is images. These are collectibles. It can be a song, it can be an image, it can be your own picture, I don't know, right? Or maybe it's completely something else, maybe your audio, right? So these are also being sold. Of course, they then use cryptocurrencies, but that's a completely different thing. So that transaction is basically on collectibles, right? So, but you have this information. So total input is 3 and total output is this one. And at the same time, later on, you'll understand there is something called a gas price. I'm not going to talk too much about it because I have only probably another maximum 45 minutes or probably half an hour. Right. Okay. So that is what do you mean by a proper blockchain? So or Bitcoin transaction. Hope that is clear. Any question? Any question?
Sir, good evening, Kanchana.
Yeah, Kanchana. Yes, any questions?
Sir, can we upload files to blockchain or just hashes?
You can. We'll talk about it. No worries. You can do that. There are ways of doing that, but you should have a specific blockchain for that. We'll talk about it.
Okay, sir, thank you.
All right. Any other questions? Right. So there's a lot to cover. Let's go on. So now this is Bitcoin. Similarly, we can now look at Ethereum. All right. So this is Ethereum. So Ethereum is a blockchain, truly, but it has a particular crypto item in it called Ether. So don't try to confuse it. Ethereum is not only a cryptocurrency, but it's a blockchain itself. So it can host many different types of blockchains in it. As an example, you can host currency or any other thing, even NFT, right? So similarly, you can find top NFTs using this blockchain explorer. So now, very simply saying, you cannot hide a single transaction in the blockchain. All are available unless otherwise the blockchain is a public or private one. If it's a public one, no transactions can be hidden from the world. That is not possible. Right? So this one was sold for 103, right? So Ethereum, that is probably few million Sri Lankan rupees. Right. Okay, that's enough about it. So we don't have a lot of time to go through this particular blockchain explorer, but now we know if you wanted to get a bit of details about what's really happening in the blockchain world, this is the place to be at. All right, so now let's quickly go through some slides again. Yes, I really wanted to show you a few things. Okay, so now I believe you understand how the blockchain works. So transaction, the blockchain, of course, atomic, and also runs independently, inspectable. Anytime it's inspectable. That's what I told you right now. You can inspect, and it's immortal. It will be there forever, right? So it's immutable, and because of that, it's immortal. And hashing, we talked about hashing is one way, is a digital fingerprint, which is used in, so normally we use SHA-256. We have seen example of that as well. And blockchain uses a principle called Merkle tree. Now, this is being changed in time to time, so I'm not going to talk too much about it. Now we know how these blocks works. Right, now we jump into Ethereum. All right, so now this is the fourth point. I'm going to do a summarization. Now we learn why blockchain important, why we need to learn blockchain, and then we understood what is a blockchain. And now we're going to look at a very specific type of blockchain that we all can learn and develop your own applications and even understand what is the problem with blockchains and probably earn millions of dollars. So let's understand what is Ethereum. Right. Any questions up to this point? So if you want to learn more about Ethereum, you have to go to ethereum.org. Yep. So yeah, you can learn a lot of things from here, and they are very user-friendly. Yeah. Okay, I forgot to mention one thing. If you want to start dealing with any sort of transaction, you need to have a wallet. And one of the famous wallets, this one called, can't remember the name of it, but this is, anyone can remember the name of this wallet? Let me go there, then you can probably see it. Let me go to the portfolio site. Yeah, it's called the MetaMask, right? It's called MetaMask. So you can create an account here, and then you can probably, if you want real money in it, you can load real money, or you can work with any, I would say, fake money and try out things. So as an example, I don't have any money here. So this is, I'm working with the Ethereum network, or I can work with the test network to test things out. I'm not going to create account here. It's not really hard, but remember, very important thing about any wallet, if for some reason, if you lose the password or truly speaking, the private key, you lose everything. There are people who basically had lost a lot of money because of, give me a second, because of people are not managing their wallets right? Give me a second, guys. Right. So because they don't manage their private keys correct, right? So this can basically be a big problem, but don't confuse yourself because of issues that people are having with wallets like MetaMask or Coinbase or Ethereum wallets. It's not the problem of blockchain, right? So there are billions of dollars lost because people do crazy things, right? So right? Okay. So that's not the problem of blockchain. We'll talk about it, but it's not really a problem, right? Anyway, I'll stop the discussion on that here. But remember, if you want to deal with the blockchain, if you want to do transactions, you really need to work with the wallet. But people are crazily secure on this aspect. So some people create their wallets using hardware wallets, meaning you will have your own, say, a kind of a hardware dongle or something like that. And there are so many other things. Okay, any questions? Any questions, guys? Hope it is clear. So let's move to the most important part, which is the understanding about security issues of blockchain. Right. So if you have any questions before that, please ask. Hope things are all right. Okay. So let me close these things and let's dive a bit more into Ethereum. So Ethereum is another very interesting kind of a blockchain or a software which resulted in giving opportunities a lot of people to create their own blockchain applications. These blockchain applications are called DApps or decentralized applications. Anybody can create a DApp. You don't need a big blockchain to get created because, say, as an example, I don't have money to create 1,000 nodes in the internet and create a blockchain. And I don't have money, right? So need millions of dollars to do that. What Ethereum is doing, Ethereum is another extra layer which says, if you guys want to create a decentralized application, we will provide the blockchain to you. But Bitcoin is not doing it. Bitcoin is a specialized blockchain. So we can't do anything else in Bitcoin blockchain. We can only do Bitcoin, that's all, right? So smart contract or the contract is already created. But Ethereum is a great one because it allows us to create our own blockchain. Sorry, own blockchain application. Hereafter, I would call it as a decentralized app or a DApp. If I want to create now, say, one of the biggest problems in the world is legal contracts. When you want to do legal contracts, it's people who know about this, you know how difficult it is. Or supply chain. We have faced the same issues, right? But we can't take the oil because of the contractual agreements. So all this can be automated using blockchain smart contracts. I still have not explained what is a smart contract. I'll come to that. But anyway, when you do build a blockchain application, ideally what you are building is a smart contract on a blockchain. So simply saying, we are going to use or we are going to write these concepts called smart contracts into a blockchain. So what I'm going to teach in the next 10-15 minutes, before I wind up the session, I'm going to explain how to write a very simple transaction or a smart contract in using Ethereum. So before that, I need to teach you a little bit more on Ethereum. So let's go on. Right. So why decentralized application? Of course, first thing is it's secure, it's trustworthy, guys. So I talked about it. Right. And why learn Ethereum? Okay. Allows creation of decentralized app. If you want to create an app, you can do it for a very minimal amount of money. Very minimal amount of money. Right. So that's a real reason why you need to use Ethereum. And it's a multi-billion-dollar industry. And there's a huge community out there. You can get help out of them. Right. Let's move on. Right, Ethereum application, of course, there are many. There are voting applications. A few of my students are doing a research project on creating an e-voting system. And legal agreements, of course. These are the contracts that you can't ever trust, right? So, and supply chain and digital ownership. So that is where NFT comes in, digital ownership. So if you can remember, Jack Dorsey, that is Twitter CEO, one of the tweets went like viral. Right, so I think you can remember the story behind that. I'm not going to talk too much. Right, and let's move on. So this is the core architecture of Ethereum. There are people who are not very computer savvy, having a programming background, forget about it. But it's not a very difficult one to understand. So Ethereum network, they have already built it, and we can build our apps on top of it. And they have provided a nice web API, so where we can build up our own applications using any web stack like Mean, Mern, whatever. Right. So I'm not going to talk too much about it. And then, of course, there are Ethereum protocol and the server side. And that is where all of you try to understand where we develop these smart contracts. And then, of course, to wrap it up, we can create any web application, very nice web application to work it around. All right. And okay, I'm not going to talk about that. And of course, blockchain, now you know the history, Bitcoin history, you know. And okay, so this is such an example, great example where we can develop. I'm not going to talk too much again. So this is an example where we can do a banking system like a cryptocurrency using Ethereum, right? So let me not go to details. This is what we explained earlier, Genesis block, and then the other blocks. So this is the blockchain, right? So I'm not going to talk too much because we have a very limited time. Really wanted to show you a real smart contract in action. Okay, so this is what you meant by immutable transactions. We learn about it in the simulation. And then a little bit about the origins of Ethereum, right? So basically, the problem of Bitcoin was Bitcoin is having a blockchain where we cannot reuse. We cannot reuse this. It's only for payments. And there's another blockchain called Namecoin that is for domain name system, DNS. And then there's another one called NXT for DeFi, decentralized finance. We cannot reuse. That was a very clear-cut problem that Ethereum CEO had seen. And he developed kind of a wrapper around it, sort of a middleware around it. On top of blockchain, he created Ethereum. Now, great things can be done. It's like a world computer, as they say it. Yeah, so now this is like this. The pager, you all know, pager was for one single purpose, right? So it was good. It was great. I don't know whether how many of you use pages. I never used it. It was beyond my time, or before my time, truly, right? Then came the all-in-one multi-purpose computer. Of course, you can do everything, calls, messages, whatever. Right, so history of Ethereum, 2013, this guy was from Russia, I believe, right? That's another great product came out from Russia. I'm not really sure. Sorry if I'm wrong. He wrote another like Satoshi, but he's a real person, right? You can search in Google. Ethereum white paper and started developing it in 2014. And this Olympic release, how they say it, 2015. And then everybody wanted Ethereum to work around. And it has its own currency called Ether, like USD. Its short name is ETH. And then it's a Turing complete language. I'm not going to explain the history of computer science on this. Guys, very simply saying, it also uses binary, right? And can be done for general purpose, meaning you can do anything that you want to. So hope you have learned about the binary computer. Now it's going to replace with the quantum computer very soon. It uses a stack-based memory. People who go a little bit more into computer science, you know how our normal everyday computer programs works. It runs in bytecode. Ethereum also, whatever the programming language we use, end of the day, it's having a bytecode. I'll show it to you very quickly. We have very limited time. It has a bytecode. So what happens is we run our code. So we use a language called Solidity. It's like a JavaScript-based language. People who love JavaScript, Solidity is the choice. People who coming from the Python background, there's another language. But I'm going to explain using Solidity here because it's easier. And what happens is it get compiled into a bytecode, and then it go and get embedded or deployed into a Ethereum middleware. And what happens? It's a bytecode. So it's a stack-based memory. Right now, up to this point, what we have is stack-based. So what happens is the code, the bytecode get loaded into the memory and the stack in the memory. And they use a heap also for dynamic memory. And then they use the processor to run things. Same logic applies here. That's why it's a Turing complete language. Because there are other types of languages as well. I'm not going to talk about those things now. So what happens here? Very interesting. So this is, again, like I said, this is one of the center of attractions. So clearly look at this slide. Right. Okay. I hope no questions. So clearly understand this slide. So Ethereum, there are two owners for any transaction. One is externally owned. Say this is Lakmal. So I have address. I have address. Let me show my address in my MetaMask. So what you are seeing here is my address. See, this is my address. This is my account. And this is my address. It's a hexadecimal value. You can, let me try to paste it to here. right? Let me try to paste it here. Let me get a Vim quickly, right? So let me paste it here. Yeah, so you can see this is my address. This is anonymous. Now Prasad asked a question, can we track? No, you can't track, guys. That's one of the, probably some of the problems that governments don't like cryptocurrency, because you can never track the person, because no such information should given to the Ethereum wallet. When you're creating the wallet in MetaMask, I don't give anything. So if I want to create another account, I just go here, go to account details, I create another account. Very simple, right? Only thing is I have to make sure my private key is secure. That's it. But this is just a hash value. This is a hash value. It's just an address. That's my account. I hope that is clear to all of you. Right,
So even
go.
can't MetaMask track the account details?
Yes, if you ask that question, it's a very difficult question to answer right now. Yeah, there are ways of capturing it. So that's why you have to be a bit secure or a bit safer when you're doing these things. I will not go into that discussion right now, Kanchana. Right. Okay. So, but yeah, that's a point. Anyway, so let's go back to understanding Ethereum. So anybody can create a Ethereum wallet, any one of you here, and then you will end up getting a address. 0x says it's a hexa value, 123, that's me, and Kanchan is having 0x2321, and that's the other person. Likewise, these are called externally owned. So I'm never going to get 20 Ethereums from like asking that no hambenne. The only person probably got the balance like this was Satoshi Nakamoto. Miniha kare mokadda miniha pay kalilla miniha avashya 20% hari 30% hari Bitcoin gatta. He's one of the biggest billionaires in the world right now. So that's one of the cool things about knowing what to do first. I'm not going to talk too much about it. And then, of course, there's another type of Ethereum that is the contract. And this is that all important oracle or middle of everything, which is called the smart contract. And within a smart contract, it's like an object in modern day programming. It's a program, right? Contract is a program where you have data and functions. And of course, data creates a state. So people who have never programmed, it will be a little bit difficult for you guys to understand it, but it's not that difficult, right? Anybody can understand a simple Python code, nothing much. So this contract also, remember, has address. So don't get confused. Sometimes you can see address. Don't think always that's a person. No, guys, it can be a contract. That's all you have to know. Then we can build out a smart contract. Let's do that because we have a limited time. So I hope that is clear. And of course, now you can see when I want, say, Lakmal wants to transfer some money to, say, Kanchana, right? So the thing is, I need to use a contract. So without a contract, I can't do. So now, and the important thing is, these contracts, no one can change. These smart contracts. That is where the real problem also. If you have a vulnerable smart contract in the blockchain, guys, you are doomed. Now, this is where I'm going to introduce you the real problem in the blockchain. So please don't understand, again, the original blockchain concept has a big loophole. No, 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 no. The problem is not with the blockchain. The problem is the smart contract that right on top of the blockchain, because blockchain is just a physical thing, but the real logic works in the smart contract. So there's a contract called send money. So if you don't write this function correct, right? Like when you develop a software, there's a vulnerable source code inside, then your software is doomed. That's how people hack you. Similarly, if your smart contract is having issues, you are doomed. Recently, there were few blockchains or cryptocurrencies had to shut down because hackers hacked the smart contract. So let me show you a nice article. Now I'm going to shut down a lot of things or close down a lot of things. This is called CryptoSec. And this is the timeline of exploit that happened to blockchains. This is where people say blockchains are get hacked every day, like Prasad does. But guys, remember, blockchain principle, there's no problem. There are no vulnerabilities, no paradoxes. Everything works fine, right? But the problem is people are not careful in putting the smart contracts right? So see, there was one, if you can read this particular hack in Coinbase, cross-chain token bridge nomad was exploited Monday. And this is a smart contract that they hacked, with attackers draining the protocol of virtually all its funds. Total value of cryptocurrency lost to the attack total near $200 million. This was in 2nd of August. So I'm not going to explain what will happen. We'll look at another one. Inverse finance was exploited for more than $1.2 million. A Thursday morning on-chain data appears to show. Right? Exploit seems to use a flash loan attack. This is a very famous smart contract attack. Right? So I'm not going to talk too much. You can, of course, look through how much issues were there in the last several years, or even for the last year in the blockchain. Right? So I'm not going to talk too much. And that's the simple reason that these guys are paying you even 10 million bounties. This wormhole. So now I'll explain to you. I told you I'll be coming to this. Wormhole is a generic cross-chain messaging protocol and allows smart contracts on various blockchains to communicate with each other. And messages are routed to chain-by-chain decentralized groups. Right? And then what they're saying is the bug report to be paid on things like this: wallet addresses where you receive the payment, proof of the address, and likewise. And then they have different threat levels. So they say ability to extract complete TVL and of all chains will resulted in giving you 10 million USDC. That's a lot of money, guys. And likewise, there are different levels that you can go into. See, so there are critical level, high levels, some low level. If you find an issue in low level in the code, you are getting $2,000. That's again a lot of money. Right. I hope I can't go very detailed into it because I have like probably Prasad, what is the time that we have to end the session?
Yeah, 7:30.
7:30. Okay, I have like 10-20 minutes. So let's go into do some smart contract, probably smart contract 101. Very simple code we'll try to do. Right. Any questions up to this point? That's the reason, guys. I will just close down everything. So these are the smart contract issues. And if you go to these two sites, Codefarina and Immunity FI or Immune FI, you can find these bug bounties that you guys can involve with. Okay. So any questions? And of course, if you go to these sites, you can find a lot of hacks that happened in 2022. Let me share those things as well. And then you'll find the reason why you should be really involved in this area. If you're in cybersecurity, obviously you should be. Even if you're in IT, you should do this. So I'm not going to read those things. You can see a lot of dollars being hacked. Total funds, $4 billion. That's huge, right? That's huge. That's the real financial issue of Sri Lanka, right? Right now, we are going to get $4 billion from the World Bank, right? So it's the same amount that they have lost. You can understand how big this is. And of course, again, top 10 DeFi hacks. DeFi is decentralized finance, of course, including cryptocurrency. Right. I'm not going to talk too much about that. Right. Any questions? Please give your feedback. If you understand nothing, please again tell me. That's important for me. Right. So now let's develop a very simple smart contract. It's not hard, guys. Very simple. So what we're supposed to do is there are so many ways of doing this. The easiest way is to go to remix.ethereum. It's like an online IDE. You can do it in Visual Studio. You can get Notepad and do it. You can do all those crazy things. But the easiest way to do a kind of a quick blockchain application. So now what we're going to do is we're going to develop a DApp, decentralized application, on top of Ethereum. I explained to you why Ethereum is easier. And they have given a platform where it's like few minutes you can develop an application, right? So this is this Remix IDE, and I don't think you need to log in even, right? So now I'm not sure whether everything is visible. So I'm going to close down everything. I don't need anything, right? So this is the IDE, and obviously I'm going to work with Solidity. So there are 5 tabs here. Again, I'm not going to explain a lot because that's not the point. Let me close down everything. So I don't have anything here in the IDE now. You have worked with IDEs, right? So yeah, so that's basically a very simple IDE. So this is the file explorer, and there are some contracts already here, right? So this .sol is a contract which is written from Solidity, right? So yeah, There's a question, maybe. Yeah, so that's a question. I'll quickly read it. Doctor, I heard that after deploying the smart contract to the blockchain, even the developer doesn't have the access to change that. If it is true, if any vulnerability is found in the smart contract, yeah, of course, that's the thing. That's why when we deploy the transaction or the contract, you have to be very, very careful. I'm like, if you don't be careful, you are done, doomed. And that's what happened for this bigger organization losing $8 billion or $4 billion because they have not tested that Solidity transaction enough, or sorry, a smart contract enough, right? And we have another transaction called owner, right? And there's another one called ballot. So there are, we don't need them, so I'll simply delete them. Yep. Okay, I'll delete this one as well. It's just enough to have a one simple one, right? Not sure whether I can zoom in a bit. Yeah, I can. I'll do that. Okay, right. And then there are other things like scripts which should test this. And of course, there are unit test codes as well. I'm not going to go too much there. It can be a bit too technical for you. So this is just the code. As you can see, it's a very simple language to understand. So as you can see, we write a contract called storage. And this is just a variable. And we here uses not integer, something called uint. This is very special for different languages. And we have a function called store. So what happens is I'm passing a value and that will be stored in this number. I can change this, say this, I can say my number. Of course, I can use the same here. And whatever the number passed will be saved here in the my number, right? And then, of course, there's another function to retrieve that value. There's a little bit things you understand here. Even I'm not going to go detail too much into it. I'll give you a very interesting resource that you can try it by yourself. This is a public, and there are other modifiers, access modifiers that you can use, like in all object-oriented languages like Java, C++, C# and all that. This is a public function. Anybody can call it. Anyway, that's not the point that I want to teach you. I really want to teach you how simple it is to deploy something into a blockchain. So this is a simple transaction. So now what I'm going to do is, let me go to the slides quickly. So when you do this, now there's a process that we need to do. Okay, let's go there. So these are the Ethereum networks. You can have public networks. This is a public blockchain. You can have a consortium blockchain, or you can have a private blockchain. Why people use private blockchain? First, they test the idea. At one point, they're going to release it to the public. That's the reason. Right. So let's quickly go through the process, how it works. I'm going to skip some of the slides. So these are some of the networks. So we use most of the time this network called RINC-B. It's a test network because we don't have real ether to test it, but the platform is providing a test network to do things really, really fast. Right. And then the most important thing is, I'm not sure whether I can find the slide quickly. Yeah, so let me demonstrate it. There are two things that we do here. One is we have to compile this code. Of course, like any program, you have to compile this code. This is a compiled language. So if you go here, right, I think it should be here. Yes. So if you go to the fourth tab, you have to select the compiler. So there are a lot of different Solidity compilers. So I'm going to keep the original one, which is there. I'm going to compile it. And then there is an error. Should be in the return number here. So what they are saying, undeclared identifier. Okay, so okay, the problem is I converted this my number, so I need to put it here. So that's fine. Probably need to save it and then compile it again. Okay, no errors, all good, right? So now the next thing is, now this is just a code that I compiled. It doesn't mean it got deployed to the blockchain. So now I'm going to the next tab. Now I need to select a real blockchain to deploy. Of course, I can go and deploy this. I cannot deploy this to Bitcoin because this is not a currency contract. This is a storage contract. Somebody asks, can I store something? Of course, you can store. So I'm going to use a test network. As you can see, there are some test networks. Remix, VM, London, Berlin, likewise. And of course, if you want, you can add it to a real Ethereum network. I'm not going to showcase that because we have only very limited time. And remember, we need to use an account. And these are all not real accounts, but like fake accounts provided by the IDE for us to test things. But you can use, if I want, I can use my real account here from MetaMask. That's possible. And then a gas limit, I haven't touched on that. And then, of course, the contract which I created, which is the one that I compile right now, right? Which is this code, right? And now what I'm going to do, I'm going to deploy it to the virtual blockchain. It will probably take a few minutes and it will get deployed. All right. And yes, I think it's all good. And once you go here, now if maybe this was earlier there, so I'm going to delete this first and again deploy it again. Right. So as you can see here, they give some messages, creation of the storage pending, and now it's get created. For all, even for that transaction, there's a hash value. Right. Anyway, so let me go and check the deployed contract, smart contract. Now you can see I have those two functions. Can you remember the function called store? Yes. So now I can feed a value like 10 and can say store. And of course, there's a message popping up here. If you can see it, the value was there. And I can retrieve that value. And you can see it called the function retrieve, and that value 10 is here. So now I was going to store 100 or 1000. Yep, it's a simple program. But remember, all this works in the blockchain and retrieve that. So I can see 1000 value here. Right, guys. So I cannot go beyond that. Really sorry about it, but we can do a real application if we had another 10-20 minutes or maybe 1 hour maximum. Right. But I hope now you understood it's not that difficult to do even a Bitcoin application by your own, or any one of you can do your own cryptocurrency. It's not a big problem. That's why there are thousands of different types of cryptocurrency, and some funny bugger created something called Dogecoin. If you have ever heard about this, it was a fun project. It's like a one-day project called. So it's a funny, like sort of a, not a scam. What do you call them? A kind of a funny thing somebody did. But what happened? Suddenly it got picked up, and this bugger called Elon Musk has put a tweet on that and bought some coins out of it, and suddenly it became one of the top cryptocurrencies. So there are this funny, or I don't know if we have to call it funny, even these things are there, right? And the thing is, yes, of course, you can develop your own cryptocurrency if you're interested. You have to do probably a little bit of studies, probably 1 hour, 2 hour study, and you can create one of your own. Right. Any questions up to this point? Because I have 10 minutes left, then I'll try to summarize everything very clearly up to this point and give you indicators where you can start this journey. And highly recommend to start this journey, because in the world, even though there are several drawbacks of blockchain, like it can be not really healthy for the nature. And because of that, probably you have heard about Ethereum left from proof of work principle to proof of stake. I'm not going to talk about that because it's a longer topic. And then, of course, there are other issues, but still Web 3.0, or as we call it, blockchain, is already revolutionized the world, and it's going to go a long way. And because blockchain is now connected with things like machine learning, quantum cryptography, and all that. But again, starting from scratch, from where I started, this is all about providing the trust and security that we all need. The same exact thing what encryption solves. And that's the reason why ISOC has created a Global Encryption Day, because people don't know the value of encryption. We need to know the value of encryption, because encryption brings us security and trust. And that is exactly what blockchain does for us. And that is exactly what they're doing right now. But remember, because the way how we implemented blockchain using these things called smart contracts, right? So as an example, you can create a contract here for doing transactions with global banks if you want to. So likewise, you can do any of those things. But the problem, if you don't do it right, and because this is a program, anybody can do a mistake when you're doing programming, right? So that's the problem. Developers do programs, they are human. And if you do a mistake, that can cost you billions of dollars. And that's what I pointed out. Because of that, there are companies like Immunify, Code Arena paying you millions of dollars to basically help you, not help you, but to give out this money to help big companies. And these are some resources. I'll quickly give it to you. If you want to start about smart contracts, there are blogs, research papers, books, and training courses created. So I'm going to share all this in the chat right now, which you can look at and understand a little bit more on smart contract security. So let me share these things to you very quickly. And you guys can have a look at those resources. So, and I have one very interesting site I really want to give you, which is called, I think, Crypto Zombies. Let me quickly get this site. Zombies, as I can remember, which you can today itself. I invite you to try this out. So it's a fun thing that you can learn about how to do a smart contract right. So it's learn to code the blockchain DFs by building a simple game. I don't have time to go through this, so let me share this with you. You know, Crypto Zombies they are very famous, right? And they have already gone into the gaming space as well. And there's a very nice course. They are also using Solidity, and there are several of them. Of course, you can go here and create your own smart contract to create a game. So as an example, there's a zombie here. Probably you know zombies. No, so the idea is like the zombies get an address which has information in it, right? And as an example, depending on what value you have here, this is 83. That does mean if you get the modulus of it, 1 is this particular figure in the head. But if I change the value to 2, this is the figure. 3, this is the figure. Likewise, zombies changes, right? So likewise, you can do all these things, and then you can create an address for each zombie. That is like a node in the blockchain, right? And then, of course, when you move ahead, you can write contracts to control these zombies. So I'm going to write a contract. So do that. It's really fun, and you will learn a lot about how to do a real smart contract and also to do a smart contract correct. Right. So let me close down things, and also just wanted to give you this link as well. So this is again from the same blockchain simulator from Anders. It will teach you about public and private keys. I really wanted to teach you this, but I haven't. I think I don't have the time right now to explain how real private key really works out in one of your crypto wallets. So because of that, I will probably give that link as well. So these are some of the resources which you can, and I believe clearly you should work on these things. And of course, if you don't really love doing smart contract auditing, you can do other things like NFT and things like that, right? And of course, you have creative ideas. You can do patents on these areas. There are so many ways that you can really involve, and you can do research. And there are, if you search in Google jobs, there are so many like jobs in this area, plenty of jobs, right? So if you search for smart contract auditing or just say smart contracts, like there are highly paid jobs in this area, right? So principal architect, digital native, so they are using DeFi protocols and they are paid a lot. Product council, cloud, public sector, so all these things are there, right? Especially in the legal arena, health arena, yeah, that's a lot of things. So let me close all these things now, and like I promised you earlier, I will stop at this particular probably the blog and explain why I wanted to talk about this a bit in the last 5 minutes. We are in a country where we have a lot of potential for people to do great things, right? So we have a great knowledge base in our country, even though people are migrating. But right technology, if we use the right technology, like machine learning, deep learning, I'm not just talking about computer technologies, whatever the other right technologies, we can build a country to make it better, right? And of course, I think there are things in our country which should be rewritten as smart contracts. So that's what I believe in. That's something very uniquely personal, but yeah, so you can use a technology like blockchain, and a lot of countries in the world have used right technology at the right time. As an example, Japan, they have worked with automobile technology and become a rich country. So I think you can read this document, and it talks about why blockchain is a great technology for a developing nation, right? So it can be a thought experiment, but still it's really worth for you to try out. All right, I think I probably took a long time. Sorry if I took overtime, but I think I got time up to 7:30. Now, if you have questions, yeah, this is the right time for you to ask questions. And of course, Kanchana shared probably another link, Metaschool. Yeah. So guys, if you wanted to learn about more on Ethereum, this should be another. So please share it for everyone. I think that'll be valuable for everyone. All right. I'm not really sure whether you got the idea. Really sorry if I covered more than expected, or like maybe if I confused a lot. But if you have any questions, I can try my best to clarify those doubts.
Yeah, Dr. Lakmal. So this one is really a good, so good overview plus good technical session. I would think that because if it's good, if you can have more time. But I think I know that we spend around maybe 2.5 hours, and it's going to be a lot of information like coming into your mind. But from ISOC, we would like you to have another session, like in detail session, maybe like a half day like workshop, right? So people can go and do some hands-on experience, and maybe creating a smart contract and all those stuff. Because you mentioned, because it's a billion-dollar industry, and then why don't we use our thoughts of coming into those areas. I know this very good area to explore, and then so thanks a lot for your information and then today's presentation. Now, if you want to give your maybe email or anything that people can follow
yeah,
up,
of course.
so you can just send, and if you want.
I shared my email in the chat if anyone wants to communicate to me. Yeah, so you guys can talk to me.
Okay, cool. Yeah. All right. Yeah. So I hope so. Today's sessions, 2 sessions we had from Professor Gihan Dias, and then Dr. Lakmal Rupsinger. And so before we wind up, I would like to invite Pujani, our president of the Internet Society of Sri Lanka, so to conduct the word of thanks.
Thank you, Prasad. Good evening, all of you. Thank you so much for our distinguished speakers for the session to celebrate Encryption Day webinar program. I take this opportunity to my heartfelt gratitude to Professor Gihan Dias to deliver an immense topic on when should you not use encryption. Sir, I hope this audience got an valuable insight on the topic. Thank you so much, sir, participating in this session. Then I would like to my gratitude to Dr. Lakmal Rupasinghe to discuss about the most current topic on blockchain security with encryption, smart contract security, and audit. Thank you so much participating, Dr. Lakmal, this session. Last but not least, I would like to my heartfelt gratitude today our moderator and organizer, Prasad De Silva. Finally, I would like to my heartfelt gratitude to our organizing committee, ISOC LK, and all participants. Thank you and pleasant evening, all of you. Next, I would like to invite Dr. Nirosha Vedasinghe to give the token of appreciation to our distinguished speakers. Dr. Nirosha Vedasinghe, over to you.
Thank you, Pujani. Thank you so much, all of you. I hope that now it's time to appreciate our today's speakers, to token of appreciation.
All right. Yeah. So
this is, yeah, I think you can see the presentation.
Yeah.
Yeah. So this is go for our today eminent speaker, Professor Gihan Dias. Next, the next speaker, Dr. Lakmal Rupasinghe. Thank you so much, Dr. Lakmal. So I think it was very interesting. And as Prasad said, we can have another sessions, and I think more people will be interesting on this topic and to get the hands-on experience on that. Thank you so much, and please kindly accept our token of appreciations.
Thanks.
Thank you so much. Finally, I would like to give our today's moderator, Mr. Prasad De Silva, for token of appreciation. Please accept our token of appreciation. Prasad.
Thanks you. Thanks. Yeah. Thanks, Nirosha. Yeah. So thanks. Thanks.
Okay.
All of your work. Yeah.
Yeah. So with that, we are going to end up our sessions and have a pleasant evening. Thank you all of you.
All right. Thank you, everyone. Good night.